When I was younger, my favorite toy was a Nintendo DS. But my second favorite toy after listing all my game consoles was a calculator. That's right, a simple calculator. Now, you may be wondering, what's so special about a calculator? Why is it such a good toy? The answer lies in the difference between a game and a toy. A game has rules, mechanisms, and goals. A toy, on the other hand, can be anything that its user wants it to be. Using a calculator to just mess around with some numbers is how I found out a bunch of patterns. For example, the sum of n terms in a series of increasing odd numbers starting with 1 is equal to the nth square number. 1 equals 1, 1 plus 3 equals 4, 1 plus 3 plus 5 equals 9, and so on. If you fix the sum of two positive integers at some specific number, you get a maximum product when the two numbers are as close together as possible. 10 times 10 equals 100 is the maximum possible product of two positive numbers that sum to 20. In fact, generalizing this when summing any number of positive integer terms means splitting the sum into as many 3's as you can, and then filling in any gaps with 2's. Hey, which naturally occurring number is between 2 and 3, but closer to 3? That's right, E, Euler's number. That's also why E is the number that happens to work with continuous compounding. Okay, I realize I've gotten a little sidetracked, but you get the idea. The calculator helps with tangential learning, a type of learning where the learner learns through exploration. And even better, they discover it through self-guided exploration. Tangential learning is an absolute staple to strategy game series like Fire Emblem, historical themed games like the Civilization series, and especially in speedrunning of any kind of game. Being able to discover new ways to make routing the game faster is something discovered through self-guided exploration, and a lot of it. A while back, I was describing how to take the sum of a series when a curiosity crossed my mind. The sum of all n, starting at 1 and summing up until m of 2n and then squared, is equivalent to the sum of all n starting at m plus 1 and summing up until m plus m squared of 2n. Another way of writing this is the sum of some partial series of the positive even numbers then squared is equal to that number of terms squared of the terms continuing from that point. For example, when m equals 1, 2 squared equals 4. When m equals 2, 2 plus 4, all squared, is equal to 6 plus 8 plus 10 plus 12, which is equal to 36 in both cases. Or, even stranger, when m equals 3, 2 plus 4 plus 6, all squared, is equal to 144, which is also equal to 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 22 plus 24, which just happens to be 9 terms, leaving off from 6, of the even numbers. I showed this to someone who knows a lot about math and asked them if it was news. I was obviously disappointed to hear that it wasn't anything new. He went on to prove it true, but I'll need to give the proof a better read-through one of these days. And even though I didn't discover something entirely new, there's an excitement to knowing that you made that discovery at all. There was a day when these were brand new discoveries. But you know what they say, the first person to paint the canvas red was a genius, and the second person to do it was a thief. So, I guess I'm a thief then. It's alright though. Thieves get tons of class perks like being great at evading attacks and gaining extra sneak attack damage. This video doesn't really have a punchline, I just wanted to share a handful of my discoveries. Thank you very much for watching, and have a great day.